Hi there, welcome to this video where we're going to cover this requested question, looking at what I like to call this probability combinatorial combined question. And I had to slow it down so I can say all of that clearly, okay? But yeah, this type of question is, as you can see, asking for the probability, right? But we're going to actually involve a combinatorial or combination or counting rule in order to help us solve this. Okay, so let's get into the question. So it reads, in a club with 8 junior members and 14 senior members, a 5-member committee will be randomly chosen. Find the probability that the committee contains at least 4 senior members. Now, of course, that's the first question, because the second part of the problem is then asking, also, what's the probability that the committee will include 4 senior members? So before we get into the actual questions to solve, let's just talk a little bit more about the information we're given. And it doesn't seem like a lot, but we need to really understand how it's all working together, right? So first they tell us that in this members only club, we have 8 junior members and 14 senior members. Of course, they don't tell us, but we essentially then can easily quickly figure out that the total number of members in this club is 22. So I went ahead and labeled that in, okay? Now, they're talking about selecting 5 members for the committee. So I called that R. Now, I should probably make these capital N and capital R for what we're about to see or talk about in a moment regarding these two questions. So that should hopefully make sense when we get to the first question. Now, the selection, and it does say randomly chosen, right? But the selection, we have to kind of make a decision here as it relates to the counting rule that we choose. Whether order matters or it doesn't. And based on how the problem reads, order is not indicated as a part of the selection process. So we don't have anything regarding specific ranks. Like let's say they said one committee member will be the president, the next will be vice president, the next will be secretariat, so on and so forth, where there's a hierarchy or there's an order to the chain of command, right? So we don't have anything like that, which means order doesn't matter. So in this case, when order doesn't matter, the counting rule, and specifically dealing with this arrangement, the counting rule that we're going to use is the combination rule. So at this point in your course, in your class, you should be familiar with this notation. So we have the NCR notation. So we're saying we have a total of a group and is run through this combination rule formula as it relates to the specific selection for that group or from that group. Okay. So of course, there's going to be a number of different ways that we'll use in calculating that, but we'll see in a moment how we set things up. So for that first question, right, we're asked, what's the probability that at least 4 of the members in this committee, this 5-member committee, are seniors? So to me that read, okay, well, I can look for the probability of just 4 seniors, but there's also the probability that there could be all of them are seniors, all 5. So I wrote P of 4, right? P of 4 seniors specifically, plus P of 5 seniors. And just a little recap or review. Remember that the plus, when we say plus, we're saying or, and this is relating to the addition probability rule. Okay, so that's why I chose to add them. But now when we get to actually dealing with the counting rule part, the calculation of these probabilities, is going to get a little bit more, well, jumbled up. Maybe not tied up or confusing, but hopefully it's not confusing, right? But it is a little bit more detailed and meticulous. So this is what I have written out. This is the setup, right? This is how what you would call the setup that helps us flow through and do our calculations. So I first write out what it is that we're looking at right here, okay? So what we're talking about here is we need to find the count of essentially how we could select a member from each member type. So we have juniors and seniors. So we have to keep in mind, we have to account for those juniors as well as the seniors that they're asking for. And then what we're doing is, because it's a probability, we need a small number over a big number, right? We're essentially looking for calculating for numbers, configuring numbers that are between 0 and 1. So that means what we're calculating, or rather the setup here that we're doing, is going to lend to that. It's going to give us fractions, essentially. Okay, proper fractions. So let me just point something else out about this setup here. Okay, for both of them, what you see is this bottom count. And this is more so like a grand total than anything. Okay, because what we're looking at there is the total number out of the total sample space. Remember capital N, 22, right? That is what we're talking about. We're talking about all 22 members and there being a selection of 5 for the entire committee. So hopefully I get my words straight here, because I did have in my head, okay. What we're saying here is we're trying to see, with this grand total on the bottom of this fraction, how many different ways we can select 5 members from all 22 members, because that's ultimately where we're selecting. We're not selecting just from the senior group. We're not just selecting from the junior group. We're selecting from the entire member or club. So really, I should say the total club and even committee. Okay, but it's ultimately looking at just the club. Okay. And so that's what we're talking about there. So hopefully this next part should really bring it all together and make it make sense, because now we're dealing with the numbers. All right, so this is the official setup with the numbers and what will lead to the calculations. So looking at this first one, okay, so remember this is our P of 4 seniors. What we're saying here is that there are 4 seniors in the committee, and that just leaves one of those spots left to a junior. Now, in terms of the combination rule, we're looking for the count. That's what that means. We're looking for the count of each type of selection. How many different ways we can select one junior from the junior group? How many different ways we can select 4 seniors from the senior group to then lead to the 5-member committee, okay? And again, this is saying how many different ways to select 5 members from the total club, right? All 22 members allotted for. So that's the setup. And I'm multiplying right here. I'm multiplying the junior and senior counts or selections, because it is, you can think about it like an and situation. It's a sequence that's happening, because it's not an either or thing where we say, oh, we could have 1 junior or 4 seniors. Not at all, because we want 5 members. So 4 plus 1, we get 5. So that means we are looking at this as an and situation, and thus we use the multiplication rule. And this is kind of going a little bit beyond probability at that point, because it's just looking at the top, okay? But you can see that that's where that thinking comes from. And I do the same thing for the one on the right. So the one on the right is the probability of all members are seniors. So we have 5 seniors being selected out of the 14. That makes 0 for the juniors, but still total 5 members in the committee. And notice too, and this is a great way to just double check and make sure your numbers are set correctly, besides the fact that what we're being asked for should coincide. So 4 should go with 14 because there's 14 seniors as it was presented in the beginning, right? But not only that, you can see that 1 plus 4 equals 5 in this group, right? 0 plus 5 equals 5. But also 8 plus 14 is 22. So everything is in alignment. Everything is set up just nicely for us to work it out. Now, I'm probably going to do this just one time, just for, video time link's sake. But, there's a number of different ways you can calculate this. Now, what I did personally is I used my TI-84 because you can plug all of this into that and it gives you the answer immediately that one time. Okay, I did that. Now, if you don't have a TI-84, or you can also do this in your TI-36, maybe even TI-30. But one of these two are pretty great. Of course, if you have the more advanced calculators beyond that, go you. Okay. But let's say you don't have a handheld calculator. And let's say you don't want a handheld calculator. You can use the Desmos website. When you go to desmos.com without um, the extra characters and the URL address. So you can see above there, it says desmos.com/scientific. So of course you can do that. But if you go to the website, just desmos.com, it takes you to the home page where it's already promoting the graphing calculator, but you're not going to use the graphing calculator. We're using the scientific calculator. So you would go to the Math Tools tab, and then it'll drop down. You'll see scientific calculator. So that's where I'm at right here. Okay, and I'm just going to show you, if you're not familiar with it, what this looks like. But of course, you can skip this part if you want. And so in this scientific calculator, a lot like the TI-84, TI-36, it has some more additional advanced features and functions that you can use. And thankfully, they have permutation and combination functions. And so we're using combination, right? And so if you click that, this is what comes up. This is different from the TI-84. So let me just compare that real quick. So in the TI-84, whether you're familiar with this or not, here it is again. So what I had to do when I plugged all of this in, I had to type the number 8 first. Then I searched and looked for the NCR function, and then I typed 1 on the right of it. So it's a way of noting the N and the R around that function to run the function in the calculator. So that's what I had to do. But in this case, what we're going to do is we have the NCR notation, and then we have the parentheses. And how we type this in then is a lot like what you may have seen in textbooks. You'll type 8, comma, and then 1. You don't need to close the parentheses with it just like that, but I'm gonna do that for this particular reason because we got multiple combinations. But there it is to the far right. We have equals 8. Okay, so it's calculated for us that combination, that count. Okay, so I'm going to show you how we would essentially type all of this, all that we have written out, into this space. And of course, you can take it piece by piece and you'll kind of see that as I type it out. All right, so the first thing I'm going to do is I'm going to type my parentheses. And already is kind of highlight, a light highlight of the closing parentheses. So eventually I'll close it. But then I'm using my keyboard, by the way. I clicked my slash button. You can go back to main and use the buttons here. Okay, so you would use like the A over B function to set up the fraction and all of that. Okay, you can also type NCR and it'll come up like that. So it's pretty great. All right, so I'm just going to back out of it though, and I'm going to use parentheses because parentheses are really, really important when you're dealing with multiple things. Okay, so I have 8C1, okay, and it's going to multiply. And you know what? I'm also going to put my little multiplication symbol. It's going to multiply with 14C4. So I have NCR 14, comma 4. I'm going to close those parentheses. So that's the top. Recall, that's the top. Okay. Now we got the bottom, the grand count, the grand total. So that's just going to be NCR 22, comma 5. All right. And I'm being very, very careful with my parentheses. I want to make sure that it calculates exactly how it should. Okay. So when I just type that, we already get an answer for that one. And I'm going to write that out too. We get this decimal 0.3040935673. Let me see. Let me just go out to I'm just going to go out to that 5 there. Let's do that. So 0.0936. Okay, so I approximated a little bit. All right. I honestly recommend though not doing that until the very end when you have to round, because most of the time with probability values, you're going to round maybe about 3 or 4 decimal places. However, since I'm writing the numbers, I went ahead and approximated it just so it's less writing, but I still went out pretty far in the decimal places. But if I was doing this by myself, honestly, I would probably write that whole thing out. So it's really up to you what is appropriate for that particular problem, and of course what like your professor or teacher is looking for. Okay, so now I'm plugging in the other probability, the probability that there's 5 seniors, and that's being added to the probability of just 4 seniors to cover the probability of at least 4. So that's again the original, right? So this is all of that plugged in. Okay, so notice that I've added all of this together, or these two together, and this is what we get. We get 0.38011169. All right, that's actually the total. So I would need to let me write what I got in my calculator. So this is what I got in my calculator. My TI-84 gave me a fraction, and then I turned it into a decimal, and that's the decimal approximated. But let me just fill in the other part. So this is what that second probability of 5 seniors would be just on its own. That's going to be 0.0760233. 0.0760233 or 234. Okay, to round it off like that. So when you add those together, this is what we get. Okay, that's the answer, the probability for there being at least 4 seniors. Okay, this is all that went down to answer that. Okay, another thing I meant to say earlier before getting into the calculations is you could also work with the formula. Okay, you are totally open to do that. So again, the formula is this right here, where you're dealing with those factorial symbols. And I would highly recommend, if you're doing it on paper especially, reducing it down so that it's easier to type it into the calculator, the rest of it, okay, to find those particular values that you would plug into each of these spaces that leads to the overall value, okay? So just a little note on that. But there's the answer, 0.3801. That's the probability. That's the percent or the chance that there's at least 4 seniors. Now, remember the second question was asking, will it include or will include 4 senior members? That to me read like will have exactly 4 senior members. So that's how I actually set it up. Okay, so the probability that we have 4 seniors in this committee, which just leaves the 1 space for the junior. Well, we've already seen this exact setup, so we actually know what this answer is, okay? Now, I ran it through the calculator again. This is what I get. As a fraction first is 52 over 171. Let me just point something else out here. So 171 may be either the actual value or a reduction, but it's related to this count here. Okay, so again, if you do it by hand, then you'll actually see what that number is before you have to reduce it if the fraction is reducible. Okay, but this is what we get as the answer, 0.304, which we've seen before. It was already in this previous problem when we were looking at least 4. Okay, so we're just taking that one part and having that as the answer, okay, because this is literally it right here, that same thing. Okay, so that is pretty much it for that last one. That was kind of like an extension of this one, or an offshoot of part A. Okay, but of course you can work through it again, do the particular calculations with each combination rule, working through those numbers and being very meticulous with those computations. Okay, so that's how you would answer, that's how you would work through to solve this type of question. I hope you found this helpful, and definitely let us know if you have any questions in the future.